Hello everyone. In this video, I will cover sections 2.1, 2.2, and part of 2.3 from the book. This is technically a review of stuff we did in chapter 1 already, so it's the same concepts, so it makes more sense the second time. So they changed the title a little bit, but we technically have done this already, okay? So if you have a right triangle, remember you call this, in this case, B, and this one A, and this one C. We already defined the trigonometric functions to be the following. Remember the sine of theta, if we put theta right here, so if theta goes here, sine of theta was defined to be the opposite, which is A, over the hypotenuse, which is C. And this is exactly how you should memorize these functions. Cosine was defined to be the adjacent, which is B over C, and tangent was equals to A over C. And remember that each of these has a reciprocal, so the reciprocal of sine is cosecant, so it should be C over A. The reciprocal of cosine was secant, so it should be C over B. And the reciprocal of tangent is cotangent, and it should be, actually tangent should be A over B. So not A over C, A over B, so this should be B over A. All right, so recall that these are called the reciprocal of each other, and also we have an identity which you should remember for forever. Remember that sine theta over cosine theta is the same thing as tangent theta, and therefore from here we know that cotangent theta, since this is the reciprocal of tangent, should be cosine theta over sine theta. Okay, so it is very important that you memorize the identities, or not the identities, the functions, the trigonometric functions, in terms of the opposite and the hypotenuse. So for example, sine is the opposite over the hypotenuse. It's not necessarily A over C. So it's not a good idea to memorize it this way. And this will give you an idea why. For example, look, let's say that now the angle you want to focus on is beta instead of theta. So this is theta, this is beta. So if this is the case, then sine of beta, the opposite of this one, it will be now A, and the hypotenuse will be C. So at this point you can say, well, yeah, see how it's exactly the same thing. But what about you wanted to find sine of theta now? See, sine of theta, see, this is theta, the opposite is now B, and the hypotenuse is now C. So therefore now sine of theta is equals to B over C. So this is why it's not a good idea to memorize it in terms of the letters. It's more important to memorize this in terms of, if you want this angle, this one, then this is the opposite, and this is the hypotenuse. If you want this one, then this is the opposite, this is the hypotenuse. So therefore, for example, you want a tangent of beta, well, this is beta, so the opposite is A, and the adjacent is B. But if you want tangent of theta, the opposite of theta is now B, and the adjacent is A. Okay, so it's very important to know which one you are trying to look for. All right, so let's do an example, and this is something that we technically have done already. Let's say that this is the given information. Let's say that I tell you the B, let's say this is B, this is A, and this is C, obviously. So let's say that the psi B is equals to A, so this is given. And so the hypotenuse they tell you is 17, okay? So the part that is missing is a. And remember, to find the missing part, you just have to use the Pythagorean theorem. So by the Pythagorean theorem, which we have used now many times, a squared plus b squared should be equals to c squared. So therefore, a squared plus 64 should be equals to 289. So just use a calculator to check this, which means a squared is 289 minus 64, which means a squared is equals to 225. And then a will be the square root of 225, which is equals to 15. So therefore, a is going to be equals to 15. Now, once you have all the size, then you can find all the identities you want. So for example, let's say that now theta was here. So if theta is there, sine of theta, well, the opposite is now 8, and the hypotenuse is 17. Now, if sine of theta is over 17, that means that cosecant theta will be 17 over 8. That should be obvious, right? Therefore, cosine theta, remember cosine is the adjacent to the angle, so it will be 15 over 17, which means that secant should be 17 over 15, and so forth. So tangent theta should be then a over 15, which means cotangent of theta will be 15 over 8. All right, let's do one last problem. In general, let's say that they tell you that this side is t, this one is p, and this one is k. So clearly here, the hypotenuse is k. It's always the opposite to the 90 degree. And then see here, I'm not gonna put A, B, or C, it doesn't matter. So this is theta, so this is the opposite side, and this is the adjacent. So if I ask you, for example, how much is tangent of theta, well, the opposite is P, and the adjacent is T. So this will be just P over T. If I ask you what is cosine of theta, the adjacent is T, and the hypotenuse is k. So this should be t over k, and so forth. Remember, you know these ones, you already know the reciprocal too. So finally, let's say you wanted to find what sine theta is. The opposite will be p, and the hypotenuse is k. So this should be p over k. All right, so the next concept here are called cofunctions. And cofunction has to do with they add to 90 degrees, kind of. So, but let me explain this with a example. So let's say that we call this one theta and this beta. And then here you call this one theta and this beta. Now, if you look closely, these are the special triangles, okay? So therefore, in this case, there's no need to call in alpha or beta. So let's say that this one is 45 degrees. This is 45 degrees, which it has to be. So alpha, you can say this is beta, and this is theta. So in this case, theta and beta are the same. And here, let's say this is 60 degrees, and this one is 30 degrees. So therefore, this will be theta, and this will be beta. It actually doesn't matter which one you call which. What it matters is that this is 60, this is 30 degrees. These are the ones that we call the special triangles. We have used it a lot in chapter 1, and you're going to use it a lot the whole semester. In fact, all your math classes, you're going to keep using this. Right? So now, what is a confunction? So here it is. Like, it will make a lot more sense with this one. So let's start with this side. So notice if we focus on 30 degrees, say theta is 30, so sine of 30 degrees. So if this is theta, the opposite of theta is 1. and the hypotenuse is 2. So you should definitely memorize this. But now notice what will be sine of beta, or in this case 60 degrees, and sine of 60 is going to be radical 3 over 2. Why? Because this is the opposite, this is the hypotenuse. All right, so then cosine of 30 degrees, notice that is equals to radical 3 over 2. So if this is the angle you want, 30 degrees, then this will be radical 3 over 2. And then finally, tangent of 30 degrees, notice there will be 1 over radical 3. Okay? So if we do the same thing for 60 and complete the triangle, this means that now cosine of 60 degrees, notice is equals to 1 over radical 2. Why? Because this is the angle you want, this is the adjacent, this is the hypotenuse. And then finally, tangent of 60 degrees is going to be radical 3 over 1. So what does this have to do with cofunctions? Well, so here it is. So notice this, look. Notice that this one is exactly the same thing as this one. And this is the same thing as this. Well, these ones are not a cofunction of each other, but look at this too. Okay, so only focus on this part. So what does cofunction actually means? It means the following. It means that sine of theta is the same thing as cosine of 90 degrees minus theta. So therefore, if theta is, for example, 30 degrees, then 90 minus 30, notice that is 60 degrees. So sine of 30 will be the same thing as cosine of 60, which is exactly the case. And the other way it works too, which means cosine theta is the same thing as sine of 90 minus theta. So this is what cofunctions are. So cofunctions just means that if the angles between sine and cosine, they add to 90 degrees, they give you the exact same value. All right, so you should definitely memorize all these values because you're gonna use them hundreds of times. I will post later a table which will look something like this, which will have all the values. So for example, you have 0 degrees, this will be 0, which means cosecant will be undefined. Then if this is 30 degrees, this will be 1/2, this will be 2 over 1, and so forth. Okay? So this is just for sine. There is also one for cosine. So cosine of x, so cosine of 0 is actually 1, cosine of 30 is radical 3 over 2, and so forth. So this is 45 degrees. This is 1 over radical 2. Therefore, this is radical 2. And this is also 1 over radical 2. And then 60, since we just talked about this, that they are cofunctions. This is radical 3 over 2. This will be 2 over radical 3. And this will be 1/2. So let's say that they ask you to simplify something like this. The question will say simplify the following. And let's say part A is you need to simplify 4 times sine of 30 degrees. Well, sine of 30 degrees from here is equals to 1/2. You can always go back to the triangles and create this and simplify the whole thing. And memorize the whole thing from here, okay? So sine of 30 degrees is 1/2. 4 times 1/2 is just 2. That's it. If I ask you to do, for example, 9 times sine of 60 degrees minus 3 times cosine of 60 degrees, so it will be 9 times sine of 60 is radical 3 over 2. Cosine of 60 is 1/2. So therefore this will be 9 radical 3 over 2 minus 3 over 2. In this case, you can just simplify the top. There's not much you can reduce, so this is equals to this. And that's it. Okay. Also, remember we have one of the identities, the trig identities. Let's say that you want to simplify sine square of, I don't know, 45 degrees plus cosine square of 45 degrees. Since this is an identity, this should be 1. But let's see if that's the case. This will be 1 over radical 2 squared plus 1 over radical 2 squared. Notice that this gives you 1/2 plus 1/2, which is indeed 1. So this checks. All right. So what you need to do is be able to create these triangles, which are very easy. These are the two special triangles. This is like the third time we talk about this. And just memorize all these values. You can always create a triangle if you forget, but I highly recommend you to create the values. I will post a table with all the values, and you should just memorize the values. Now, what about if the triangles are not special triangles? Then you cannot find the exact value. You have to use a calculator. So that's what we're going to do next. Okay, so now a little bit of notation. This means 1 degree is equals to 60 minutes, and 1 minute is equals to 60 seconds. So this is what this means. So this means 1 degree is equals to 60 minutes. Okay, and this means 1 minute is equals to 60 seconds. Okay? All right, so the conversion ratio is the following. Notice that 60 minutes divided by 1 degree should equals to 1, or that 1 degree over 60 minutes should be equals to 1. So this is the conversion factor. So for example, you want to add or subtract angles in this fashion. It's pretty simple. So let's say you have 11 degrees and 41 minutes plus 32 degrees and 16 minutes. So you add the degrees and the minutes separate. So here you will have 43 degrees and this is 57 minutes. Now, as long as this number is less than 60, you don't have to modify anything. But if it goes over 60, you have to fix it. And by that I mean this. Let's say you have now 11 degrees, 41 seconds. Sorry, 11 degrees, 41 minutes. Plus, and I said this was 32 degrees, 35 minutes. So now notice that this one will be 43, just like if it was. But now this is 76 minutes. 76 is more than 60 minutes. So therefore notice that 76 minutes is the same thing as 60 minutes plus 16 minutes. But 60 minutes is exactly the same thing as 1 degree. So therefore this will be 1 degree plus 16 minutes. So therefore this one should be 43 degrees plus 1 degree. It will be 44 degrees plus 16 minutes. So this is the proper way to write it. It's not that this is wrong, but this one has to be less than 60. So this is how you will fix the problem. Now, how do you change from just degrees to degrees and minutes? Let's say, so this is another example, that you have 83.6 degrees. So all of this is just in degrees. And let's say you want to change this to degrees and minutes. So clearly this will be 83 degrees, but what about the 0.6? So this is how you deal with the 0.6. You have 0.6 degrees, and remember that you can use either this one or this one. How do you know which one you had to use? Since you want to get rid of the degrees, you had to use the one that has the degrees on the bottom. So you had to go with this one. So you're going to multiply this times 60 minutes over 1 degree. Notice that the degrees will cancel, and this will give you 36. Use a calculator to check that. So it will give you 36 minutes because you still have the minutes left. So therefore, 83.6 degrees is exactly the same thing as 83 minutes and 36. 83 degrees and 36 minutes. Now, sometimes it's much easier to just plug in this value in the calculator than this, but you need to understand that this is equal to this. Now, you cannot find the exact value for this. You just need the calculator. You need to make sure that the calculator is on degrees. Use your calculator, and this is how you know this is correct. Sine of 83.6 should equals to 0.99376. You use the calculator and make sure that it's on degree, not radian, degree mode. Okay. Now the only thing you have to watch out is the first two things when you use the calculator. Make sure that it's on degree mode because you have degree and radian, depends which calculator you're using. And also the calculator only has sine, cosine, and tangent. So therefore, if you wanted to find, for example, cosecant of 83.6 degrees, you cannot find cosecant directly, but remember cosecant is just the reciprocal of sine. So all you have to do is do 1 over sine of 83.6, and that should give you the answer. So if you do 1 over 0.99376, this should give you 1.00627 and so forth. Okay, let's do one more example. Let's say that they ask you to find the following, which you need to use the calculator. Let's say they ask you to find how much is cosine of 40 degrees in 25 minutes. Okay, so it may be a little annoying to convert this to decimals or to type it. You can technically type it like this on the calculator, so it's easier to change this to decimal. So for example, you already have 40 degrees, so all you have to do is convert the 25 minutes. So you're going to multiply this by 1 degree over 60 minutes. So notice that the minutes will cancel, and this will be 0.41667. So you round it to two places, it will be 0.42. So therefore, this is the same thing as cosine of 40.42 degrees. And then just use a calculator, and that will give you 0.7633. And that's it for 2.1 and 2.2.